So, dear students, I welcome you for this lecture series of chemical equipment design. Today we are going to discuss to the storage tank dikes. Now, the large storage tanks in case of your refineries and petrochemical plants and your heavy chemical plants, you require a very large storage capacities like in 1 lakh liters, 10 lakh liters, even 1 crore liters also, with a tank size of say 15 meters, 20 meters, 30 meters, even up to the 100 meters also, the tank diameters that will be. Now, when you talk of such huge dimensions of say 100 meters diameter and a height of 30 to 50 meters height of a tank, such a huge volume that is more than 1 crore liter, 10 crore liters capacities that will be there. You require a minimum of 15 days working fluid that is required, and to fulfill that purpose you require such huge tanks. Say for example a crude oil that you are importing it from the Arab countries, and if some problem exists in Arab countries because of certain lockdown, say for this COVID situation also, there is can be lockdown and you cannot get the crude oil because of restrictions imposed on the individual countries. So you must have a certain minimum storage capacity of at least 10 to 30 days. Again, that depends on the type of a process industry. So you require such huge capacity tanks, and these tanks are there in the tank farm where they should be fire and explosion and hazard free environment. Now, to prevent such hazards from one tank to another tank, you provide a dike. This dike that is nothing but a protective area around a tank. Now consider this as your tank, and you are putting a certain retaining wall. This retaining wall that is called as a tank dike. To have the tank safety, every storage tank is surrounded by a retaining wall to hold the tank contents in case of a rupture. That is the basic purpose, to retain the fluid in the tank area itself. In case of a rupture, whatever the fluid that will be dispersed from this tank, that will be retained by this retaining wall. So in this area only the fluid content that will be dispersed. Now this figure is before the rupture and this is after the rupture. So some problem exists in the in this tank and the fluid that is dispersed in the surrounding area. But we are restricting this fluid not to go out beyond his retaining wall. सो इस रिटेनिंग वॉल के बाहर वो फ्लूइड नहीं जाएगा. A boundary, a compound wall that is provided around the storage tank. This this compound wall is similar to our house compound wall. We restrict ourselves. NMC has restricted your activities in that compound wall only. So by providing a storage tank dike, we are going to restrict the movement of the fluid within that area only. Now, what should be the optimum size of this retaining wall and how that is determined. Now, H1 is the height of a fluid in the tank. Initially, H1 is the height of a fluid in the tank. Now, after the rupture, this height is reduced to the H2. R is the tank diameter and A is the area or the space around the tank. Space around the tank means total A plus R, that will be the radius for this retaining wall. A plus R, that will be the area or the length for the retaining wall. So we have to consider the different areas. One is the area for this tank and the second is the this area that is around the tank.